Hello and welcome to Oliveboard platform and very good morning to all of you. Hi, good morning everyone. I hope so. I'm audible clearly. Please do let me know in a comment box before starting a session because this is a theory class of your heat and thermodynamics. So my voice actual matter. Okay. So hi. Good morning guys. Good morning Divya. Good morning Ravi ji, Jitendra ji, and BSG. Hi. Very good morning, guys. Good morning, everyone. Okay, so let's begin a session which is based on your thermal properties of matter. You can say, you can also call it as a heat and thermodynamics. You can also mention as a simple heat. Okay, so let me tell you the content of the chapters, meaning what are the main concept we need to cover under this particular session. So first of all, starting as the name suggests that your chapter name is heat, right? So obviously you need to cover first of all heat, what is a heat, what is heat energy, and so on. Unit of heats, what is temperature, what are the temperature scales, okay. Then after thermal expansion, a very important and paining point under this chapter. Then after, because heat is a form of energy, so obviously it will transmit, it will transfer. So what are the modes of transfer or what are the mode of transmission of heat energy, right? These are the important part. Apart from this, we can say there's a small type of definition. For example, conduction, in a mode of transfer of heat, we need to cover the conduction, convection, radiation. But not only a definition, we need to cover the applications of conduction, application of convection and radiation. Apart from that, Newton's law of cooling, very important. Then after, a very important thing, for example, evaporation part, the concept of evaporation, refrigerators applications, right? And also a latent heat. Okay, these are the content of this particular chapter we need to cover, starting with the very first definition, guys. And your first definition is basically, we can say, as the name suggests, that's your heat. Here I'm telling you that what is heat. So simply, do not see the board first of all. See, so actually we can say that heat is a form of energy, right, which is always transient due to a temperature difference. Now, what is temperature difference? For example, you have a hot cup of tea, right? And you just place that hot cup of tea on a particular surface. After some time, you will see that particular surface is also somewhat heated, right? Why? Because the temperature of the cup and the temperature of that bed sheet was completely different. There's a temperature difference, and because of this temperature difference, the heat transfer from higher temperature difference to the lower temperature difference, so that it will equalize. Okay, so today, because of this temperature difference, the heat transient and it is a form of energy, we can say here. Okay, the first of all and the very important definition. Apart from this, heat is an internal energy of molecule constituting the body. Okay, it flows from a hot body to a cold body, and heat is a form of energy, the simplest thing, right? All the substance in our surrounding are actually made up of atom and the molecule, and definitely they have some space, and in their space, whenever we raise the temperature, they get heated, and once there's a temperature difference, that heat energy transfer from a hot body to a cold body. Clear, everyone? Anyone having any issues regarding this? Now we more talk about the temperature part, the unit of the heat, or basically what is the heat part. So see here, this is complete examples. Okay, leave it. Now what is the unit of the heat? So the unit of the heat is joule, first of all. but this is an SI unit. What is the CGS unit of heat? So CGS unit of heat is arc. Okay, so here you need to cover your two units part. First is your SI unit, joule, and simply the second unit is your arg part. Clear? Any issues here? Now, in this case, actually, sometime they can ask you a question, what is the relationship between this 1 joule and this arg? Keep in mind, 1 joule is equals to 10 to the power 7 arg. Now, this is a relation between SI unit and CGS unit of your heat section or the heat part. Clear? Okay. Now, the second thing is calorie and kilocalorie. This is also just another heat units of heat. 1 calorie is always quantity of heat energy required to raise the temperature of 1 gram of water through 1 degree centigrade from 14.5 degree centigrade to 15.5 degree centigrade. That means your 1 calorie is the amount of heat which required to raise the temperature. And what is the what will be the range of that temperature raise? 1 degree centigrade, that is from 14.5 to 15.5 degree centigrade. Sometime they can ask you a question, 1 calorie is equals to how many calories? Simply 1000 calorie. 1 calorie is equals to 4.2 joule. Very important data in this section. Now, so basically in a case of heat, right, as we know that that heat somewhat associated with the temperature section, or we can say a temperature. So what is temperature? Temperature is basically a degree of hotness, okay, and coldness which is measured by a physical quantity and call it as a temperature. Or we can say temperature is basically a relative measure, right? Or for example, if I ask you what's your body temperature and you just tell me it's around 102, that means your body is too hot. If it is below 98, your body has normal cold part. So actually temperature is telling you the any object hotness and on any object coldness. Okay, so here we can say that temperature is a relative measure or indication of hotness and coldness of any body or of any object part here. Clear? So basically temperature measures, see why this hotness and coldness occur. See the concept. For example, this is a rod. Okay, once this rod is consist of a different atom and molecule. Okay, now you start raising a temperature by heating it up. Okay, after some time you will see this particular molecule start vibrating at its position because it hot or raise the temperature. Again, due to the vibration, it also push the another molecule. After some time, this particular molecule push the another molecule and so on. So actually here we can say that temperature measures the average kinetic energy. I think from your starting physics, you have already heard about it. Whenever the temperature raise, whenever there is a heat part came, the kinetic energy of any substance got increased. Now this average kinetic energy is measured by, or the kinetic energy of any substance or kinetic energy of any particles are measured by which part? So it is measured by the temperature. Clear? So temperature is just an indication of your hotness, of your body hotness or the coldness. It is also a substance basically or a term by which we can measure the kinetic energy of particular substance too. Okay, any issues here? No. Acha. The another thing we can say that hot utensil is said to have a high temperature and an ice cube has a low temperature. This is just a benchmark for our upcoming part. So actually, whenever there's a object which is actually which has a higher temperature, then other object is always considered as a hotter, and any object which has a lower temperature as comparison to any hotter object is considered as a colder. These are the just basic part I was telling you. Any issues here? Okay. Can somebody tell me what is the difference between heat and temperature? Any inputs? If you are a little bit clear about any concept. Anyone? What is the difference between temperature and heat part? Any basic word, basic thing if you know. Whether it is regarding a unit, whether it is regarding a definition or something. Anyone? Temperature is a measure of heat energy. Okay. Okay. So, somewhat say heat is a form of energy, right? It is a form of energy. While temperature, absolutely right, temperature measures heat energy. Okay, or temperature measure the average kinetic part. Okay. On the other hand, we can say that heat is measured in calories or in joule. Okay, the second thing. But here the temperature can be measured on a different scale. Scales like Kelvin, Celsius, okay, then after your Fahrenheit and Rue. Okay, so this is also just another difference. Temperature is a measurement of heat, okay, and heat has an energy and temperature is measuring. Okay, we can say also heat represent total internal energy. Okay, while temperature indicate the hotness only, heat represent total internal energy, while the temperature indicate only hotness and coldness of a particular object or a particular body. Okay, also heat always flow right from a hotter part to the cooler object until thermal equilibrium reached, while temperature determines the direction of heat transfer, right? It determines the direction of heat transfer, right? On the other hand, heat flow from hotter substance, hotter object to colder object until the thermal equilibrium maintained. Okay, clear everyone? So this is the basic difference between the heat and the temperature section. Now okay, so here we can say there's a different temperature as here. See, temperature is basically the indication of hotness and coldness, and to determine this temperature we need some scales, whether it is a Kelvin, Celsius, Fahrenheit and other. See, first of all, the basic part is the scale. So actually there are various type of scales of temperature by which we can measure the hotness and coldness. So there, as you can see here, we have around 4 scales. First is Celsius. Andreas Celsius discovered it. Fahrenheit, Reaumur and Kelvin. Ice point is 0 degree Celsius, here 100 and difference is 100. Fahrenheit, 32 Fahrenheit is the ice point, freezing point, and 212 degree Fahrenheit is a boiling point. Then after 0 degree Reaumur, 80 degree Reaumur and Kelvin 273K and 373K. Okay. Yes, I will share. Anyone facing blur screen? Please confirm if you are facing any network issue or glitch. Anyone? Anyone else also facing this network issue or glitch something? Huh? Blur screen. Video quality is very low. Just a minute. Totally blur. Not on my screen, but just a minute. Switching my network. Please have some patience. Still blur? Please refresh your page, everyone. And do let me know if you are still facing a same blurriness. Wait. Still blur? Please confirm. Network issue. Are you guys able to hear me? Everyone? Please confirm me. Still same? Now okay? Now clear? Okay. Okay. See. So these are the 4 major scale by which we can measure the temperature. Okay. Please note it down that Kelvin. Okay. No degree symbol is attached in a Kelvin. No degree symbol in case of Kelvin. Okay, clear? And also the temperature of a body can never be less than 0 Kelvin. Okay, just a big point. Zero Kelvin. Okay, now the major issue in this particular chapter is the numerical. Sometimes they can ask you a question like 40 degrees centigrade, what will be in Fahrenheit? Okay, so actually here we need to set a relationship between these four scales via a simple formula, and you can apply that formula anywhere. Okay, so what is the formula and the relationship between the various scale? So this, sorry, okay, so the formula and the relation you can set up among these formula, or basically these temperature part is here. Okay, that's your C, not mentioned or what. Okay. Okay, C upon 5, here C is your Celsius, equals to F minus 32 upon 9 R upon 5, okay, and K minus 273 upon 5. So this is a simple formula by which you can calculate any temperature degree into, or you can convert any temperature degree into a different degree. For example, see here. For example, if I ask you a question, what is 0 degrees Celsius in 0 degrees Celsius in Fahrenheit? Just apply only this part, C by 5 F minus 32 upon 9. Now you can solve it. At the position of C, take it as a 0. Please try to solve it. 0 degrees Celsius in Fahrenheit. Anyone can calculate this? C by 5, F minus 32, R by 5 and K minus 273 upon 5. Anyone? Can somebody please calculate? 32? Sure? Okay. Because for that part, okay. 0 degree Fahrenheit. You can also calculate via 40 degrees centigrade. Please answer. 40 degrees centigrade in Kelvin. Now, 40 degrees Celsius in Kelvin. C by 5 Kelvin. So K minus 32. Sorry, K minus 273 upon 5. Answer. 40 by 5 is equals to K minus 273 upon 5. Solve this, around 8 is equals to, right, K minus 273, sorry, 273 upon 5. Solve it. Keep this K here. I'm switching the steps, okay. K is equals to 273 plus or minus plus 40. Now, 313 degree, sorry, no degree, Kelvin. Clear? Okay. So, whenever they are asking you a question, this conversion to this conversion, take only those formula. Okay. For example, in a Fahrenheit to Reaumur, only take this. From degree Celsius to Reaumur, take only this and this. Fahrenheit to Kelvin, F minus 32 upon 9 and K minus 273 upon 5. Simple. Anybody having any doubt regarding this conversion? Because even in a question session, in a practice session, there's a lot of question on a conversion based. Okay, Divya and Ravi and Charlie, huh? Okay, anyone having any issues, right, guys? You can calculate easily, right? Okay, now. So there's no need to take a relationship between separate formation. For example, in a theory section, I am giving you the separate relationship. For example, relation between a Celsius and Fahrenheit. In a next slide, you will find relation between Celsius and Kelvin. In the next slide, Fahrenheit and Kelvin, and relation between Celsius and Reaumur. So by that formula, you can just set a simple relationship between all the scales. Okay, see here. Now we are not moving to the temperature part. See, the next thing here we need to cover, that is your thermal expansion. Now what is thermal expansion? As the name suggests, most of the substance expand on heating, right, and contract on cooling, simple form, and this is what a thermal expansion. So expansion of a substance on heating is called thermal expansion of that substance. Solid, liquid, gas expand on heating and contract on cooling part. Clear? So whenever there is a change in temperature of a body, cause change in its dimension as well. Okay, the increase of the dimension of a body due to the increase in a temperature is always termed as a thermal expansion. Okay, now whenever this expansion in length, right, it is termed as, or it is called as linear expansion. Okay, whenever the expansion in an area, it is termed as area expansion. Okay, and whenever there is an expansion in volume, it is termed as what? Volume expansion. Okay, I think it is also mentioned here. Now, first of all, let's consider the examples of thermal expansion, because a lot of time they can ask you just a simple application of the expansion. Acha, okay, leave. See, first of all, let's consider the thermal expansion in solid. So see, when a solid is heated, it expands in all direction. Okay, that means increase in length, that means linear expansion. Increase in area, superficial expansion or area expansion. Increase in volume is called cubical expansion and also a volume expansion. That means in a case of solid, whenever we are providing a heat or any heat energy it receives, it will expand in all direction. Okay. Now the application of the expansion of solid, first of all, the iron ring of a cart wheel has a radius slight less than that of a wooden wheel. The rim is heated and then fixed onto the wooden rim. Then after, your railway tracks are always having a small gap because of the thermal expansion, because in a summer there is a expansion in solid and in a cold or winter there is a contraction in that particular metal. While lying concrete roads, there's a small gap on a bridges, right? A one type of line always create at a particular distance. So always the gap left. Again, the reason is thermal expansion, because in a metal, in a summer the metal expand, in a winter the metal contract. So to maintain that, telephone wire sag more in summer and in winter due to contract in winter due to the expansion. Hot water is poured in a glass tumbler, it break because the interior part, the internal part where the water kept expand, and the external part, the exterior, remains same, and due to this difference it always break. Okay, so these are the simple applications of your expansion part and the expansion in solid especially. Okay, they will ask you a question like this. Wait, I'll show you. question. I don't know where it is. Okay, okay, leave it. Not able to find a question exactly. See here. Now, moving to the next part, and that the next part in a case of liquid. Actually, in a case of liquid, the main thing is water, and in a case of water, there's something different happen. See, it is termed as the anomalous expansion of water. Actually, all liquid in general expansion on heating, but water exhibit a peculiar behavior. Now, what is kind of this behavior? So when we heated up water from 0 degree centigrade to 4 degree centigrade, okay, it contract, and on further heating it starts expansion. So 0 to 4 degree centigrade it always contract, and after that it starts expanding, and this is termed as anomalous expansion of water, and the density of water is maximum at 4 degrees centigrade. This is a reason that on a frozen lake or a frozen river has the aquatic life alive because of this anomalous expansion of water. See here. Now, the consequences here. So, in cold country and hill station, the water pipe generally burst in winter due to the expansion of water. Aquatic animal can survive in a frozen water body through surface is frozen, and water below the surface is 4 degrees centigrade and hence in a liquid state. In extreme cold, vegetable and fruit get damaged as the water pressure can burst them open. Okay, so these are the applications of anomalous expansion of this. Now, as in a starting part, we have heard that heat energy always flow from a hotter region to a colder region. Just a minute. To a colder region. Okay. Now here, so in a case of heat, that means we know that heat energy can flow. So because heat energy is flow, so there is some mode of transfer of heat part, and this transmission always take place by a 3 different process. Now the 3 different process are conduction, convection and radiation. Application of these 3 transmissions are very important for your exam point of view. See, first of all, the conduction part. Now, what is conduction? For example, we have a one iron rod. Okay, as we know that this iron rod is consist of a small molecules or particles or atom, right? Okay, we start heating it, right? We give a heat to this particular iron rod. Now, as we know that this iron rod is consist of a small particle, okay, and from the chapter of matter, as this molecule raise the temperature, or when they get a heat, they start vibrating at their own place, right? Which is also termed as a kinetic energy of the molecule, right? So, for example, these are the molecules at the surface. Firstly, they get started vibrating. Okay, they also push the another atom or a molecule and also initiating a vibration to the another, and so on, right? So actually the molecules are not moving from their position, but due to the vibration at their own place, own place, they start moving this vibration, and all the atom and molecule after some time get heated, and a person who was just holding this rod also receive a heat. So through this atom part, through this molecule part, a whole rod get heated, and this is what a first transmission of heat, which is termed as conduction. So actually in a conduction, the particles are just vibrating at their own position, and by a simple push or pull kind of thing, it start moving, the whole heat energy start moving from a one end to the another end, and this is how the transmission occur, and this type of transmission is termed as conduction. See here. Now in this process, heat energy flow from one molecule to another molecule in a solid without their actual movement. That means in a conduction, there is no actual movement. No actual movement occur of particles or the molecule. For example, when one end of an iron rod is heated and the other, okay, when heat flows easily through a given substance by conduction, it is said to be a good conductor of electricity. Okay, because this iron rod, the heat is easily moving, right? The particles are easily transmit their heat energy from a starting point of iron rod to the end point of iron rod. That means this iron rod is a perfect example of a good conductor. So whenever the heat is able to flow from the vibration of a particle, that particular substance is termed as conductor or a good conductor. Okay. Now, when a substance does not allow heat to pass through it easily, it is a bad conductor, or you can call it as a insulator instead of bad conductor. Okay, so actually in a conduction, we have two terminology. First is a good conductor, second is a good insulator. A substance which cannot flow that heat transfer through the vibration of a molecule is a insulator, and a substance which allow the heat transfer through the vibration of a molecule is a conductor. Clear everyone? And lot of concepts are based on this insulator and the conductor part. So if this concept is not clear, just do let me know quickly. But clear? Are no clear? Clear? Yes. Okay. Okay. Clear. Now, as I have told you, applications are very important here. So applications of conductor. See, the substance which do not allow any heat to pass is the insulator, right? And when we wear a woolen clothes are actually a good insulator because they cannot pass the heat energy, right? So there's a lot of concepts. See here, mercury is used in thermometer. Why? Because it is a good conductor of heat. For example, in a thermometer, this is a mercury, right? It got this temperature or the heat. Now after some time, this particular molecule also get heat and start vibrating, and so on the temperature raise. Clear? Example of conductor. Eskimo, the snow house you have heard, right? Eskimo lives in a snow huts called igloo because snow is a poor conductor. How? Because snow can trap heat energy, right, and shield them from a cold part. Automobile radiator, air conditioner, refrigerator use tube made up of copper, and as it is a good conductor of heat. Same in a case of geyser, good conductor of heat because copper used. We wear woolen clothes, very important, and use blankets in winter as they contain a large amount of trapped air, right, which is bad conductor of heat, will not allow a flow of heat, okay, and prevent the loss of heat from our body. The handles of appliances like electric iron, pressure cooker, oven, these are the bakelite, right, consist of bakelite, a type of thermosetting plastic, and they are the poor conductor but a good insulator because they can trap the heat, right, that heat will not flow through a handle. So also this is a perfect example of conduction. Any issues? Poor conductor means insulator, we can say whatever the substance is a poor conductor is actually a good insulator, okay. Any issues here? Wait. Okay. Moving everyone, just a minute. Just give me a minute. Okay. Now, so this is a first heat transmission process. That's it. That is conductor. Second transmission is convection. Now, what is convection? See here. In a case of convection, right? So actually in a convection, the heat transfer through the actual movement of molecule. Now, how does actual movement of molecules occur? For example, we have a one container, right, and it is filled with a water, right. You just put on a gas and start raising a temperature, okay. After some time you will see the molecule which is at the bottom of the container or the utensil, right, getting a heat first, okay. That means they are that means they are getting a heat, right, and because they are getting a heat, so obviously the weight lose, right, and once the weight lose and they are light in weight, they start moving upward, okay, and the heavier molecule which is at the top of the container, okay, as they see that there's a one gap, start moving downward, okay, and the whole process goes on. Right, okay. Now this is what are actual movement of molecule. In a conduction, there was the molecule was not changing its position, but in a convection, the molecules, the atoms are changing their position, and then after get heated by a process is termed as convection. Clear? Simple? See here. The transmission of heat due to movement of molecule, okay, from one place to another place is called convection. For example, conduction is very good happen in a solid only because the molecules are very close to each other and they can vibrate and push the other molecule too. But in a case of convection, occurs only in liquid. Okay, because for a convection there must be a flowing process. See here. Now some examples. The applications of convection is ocean water in tropical region become hot and moves towards colder polar region to the hotter region, and also create a warm ocean current. Okay, example of convection. Heating element heated by a convection current. Sea breeze, land breeze are formed due to a convection current. Unequal heating of earth set up convection current in a air, leading to a formation of wind. Clear everyone? Any issues here? In a case of convection, in a cooking also, the circulation of air, we can cook lot of things. In a ocean current, convection contribute. In a geological process, convection contribute. Okay, in a cooling system of electronics, convection contribute. Clear? Any issues here? No issues. Okay, moving to the third process or the third mode of transmission, that is called radiation. Sometime any object which is very hot itself, okay, actually, so any object which is very hot itself, right? So to get this hotness, it start removing, or it start giving that heat in a form of different wave, right, which is not visible directly, but it also due to this wave, the other object is also hot, okay, or receiving a heat. It's termed as radiation. See, for example, the perfect example is sun. Sun is a perfect example of radiation. Sun is completely a hot body, right? And because of this hotness, it start removing that hotness through some kind of waves, and also raising the temperature of earth or any other object is an example of radiation. See here, in this process, the heat transmission, a material medium may or may not be present between a hot and a cold body. The heat energy exchange between the two bodies is called a radiant heat or thermal radiation. So the thermal radiation are electromagnetic waves. Thermal radiation can travel through vacuum. They do not heat the medium through which they pass. In a geyser are fitted near the bottom so that the water can be hot. Clear? Radiation part or not? See, application. Shining surface are good reflector of heat, so the roof of the factories are painted white, and the cooking utensils are blackened at the bottom so that they can trap the energy, they can absorb the heat energy more and more. To keep tea hot, for a long time, teapots are kept shining, as shining surface are a bad radiator. Okay, the base of an electric trawler is highly polished so that it does not lose heat by a radiation. Clear everyone? Any issues here? Time is 53. Okay, clear this? So actually we had three radiation part. First was a conduction, only a movement, vibration of the molecule. Convection, actual movement. Then after radiation, a whole body itself, due to a hotness, start moving or removing a electromagnetic waves, and by this waves, a particular or next body get heat. Okay, third point. Okay, first and third point. See, because tea hot, keep along, teapots are kept shining, because shining surface are actually a bad radiator. Bad radiator means a substance which cannot allow the heat to flow. Okay, that means they can absorb the heat, they can trap the heat, and by trapping the heat, they will maintain the tea hot. Okay, see here. I think you guys missed this point. See, the heat energy exchange between the two bodies. Okay, whatever the heat energy exchange between a two body is called a radiant heat or a thermal radiation. Now, thermal radiation is electromagnetic, and radiation can travel through a vacuum also. They do not heat the medium through which they pass. That is why they can trap the energy, and then after they kept the tea hot. And first and third. First is shining surface are a good reflector, right? Reflector of heat. So the roof of factories are painted white because, as we know, the black board and the black clothes are trapped energy more. So shining surface always, for example, this is a shining surface and this is a black surface. Okay, now the heat is coming, so black surface will always absorb the energy or the heat energy, while shining surface reflect this heat energy, reflect. So for cooling them, the factory roof, they are painted with a white color. Now clear? Anyone? See, now moving to the next part, and your next thing is Newton's law of cooling. Sometime you will receive a question from this segment too. Now, what is Newton's law of cooling? So he stated that the rate with sorry, the rate with which a hot body lose heat, okay, is directly proportional to the difference between its temperature and the surrounding temperature. For example, we have a hot water, right? And also this hot water and fresh water put in a refrigerator. The rate of cooling of a hot water will be faster than the fresh water because of its surrounding. It is directly proportional. So directly proportional of its surrounding temperature. If the temperature, the surrounding temperature is cool, so definitely the particular object or that hot glass water start lose its heat more rapidly as comparison to a fresh water. Okay, and put in a refrigerator, rate of cooling of hot water will be faster than the fresh water, and hot water takes less time in cooling from 80 to 70 than in cooling from the 30 to 20. Means the surrounding matters. Okay, for example, I think you have seen this process in your home also. Aloo ka paratha. Okay, so when your mother usually stuff cooked, right, always keep in a under a fan, right, so that it start losing heats rapidly. Okay, clear? This was the simple thing which was actually stated by the Newton's law of cooling. Now the heat capacity, but I think, what is the time? 57. Some concept left, evaporation left, latent heat left. Okay, in your next class we will cover these concept. I think two concept left your latent heat left and 58. Okay, latent heat left and also this evaporation method left. Okay, and this particular PDF containing a questions, everyone, so please try to attempt these questions. Once you try and not able to get an answer, only in that case you can ask a answer PDF, but please at least attempt it for first time for yourself. Okay, now feeling starving. Okay, had no breakfast. Okay everyone, so here we have completed, but please in your next class, please remind me that there are two concepts left, latent heat and evaporation. Can somebody please remind me in your next class? You can get your PDF. See, for example, this is your dashboard. Okay, how you will get your PDF? This is your dashboard, looks like. The student dashboard will be a little bit different, but I'm telling you. Okay, in all or in today? Okay, in today's section, once the class done, you will receive your PDF here only. Watch now and download PDF segment. I can't show you actually right now. I can't show you because this is a new batch. For example, see this, download PDF, watch, download PDF, watch. So here you can download this PDF like this. Okay, clear everyone? Okay, please check and let me know. If you're not able, then I'll help you. Okay everyone, so here we have completed this session. Thank you so much. Please download the PDF by end of the day today. Okay, thank you so much. Bye bye and take care, and please remind me for your next class we have 2 concepts to cover. Okay, thank you so much. Bye bye, take care. One more thing, this was your class of your SSC Foundation Batch 2.0. So if you are definitely okay with this batch, you can check the same batch on the application, which is your SSC Foundation Batch 2.0. Okay, thank you, bye bye and take care.